Hello there, this is Ms. Page. In this lesson, we are going to talk about how to identify the shape of a cross-section. And so first we want to start by defining a cross-section if you're not familiar with that term. So a cross-section is a flat surface region of a plane that intersects a three-dimensional figure or solid figure. They sometimes turn out to be simple figures, which are the ones that we're going to be looking at here, such as triangles, rectangles, and circles. And this is one of the things that we sometimes have to do in calculus problems. We have to be able to identify a cross-section and what kind of solid it would create, or given a particular solid, what would a particular cross-section of that solid look like. So here we are looking at a cone that is being intersected by a plane. So this gray rectangle, square, whatever that is, that's the plane that's intersecting the cone. And so what we're looking for is where it intersects on the sides of the cone. And so here we would find that here's on this edge here. It intersects over here on this edge. And then it also intersects as it goes through the bottom. So the shape that we get is here, and it can sometimes be helpful to shade that in or outline it as I have done here. So that right there is what we refer to as the cross section. And now we want to identify the shape of that cross-section. So you might recognize that shape as a triangle, which is good. But one of the things I want to point out about this particular figure is that our cone is a right cone, which means it's symmetrical, which means that the side here of our triangle and the side here of our triangle would have to be the same length, making them congruent. And we don't know about the bottom edge. It's very likely a different measurement, but we can be certain that these two sides would be congruent to each other, which makes it more specifically an isosceles triangle. So when possible, we should indicate more specific figures as well. So instead of just triangle, we're going to here call this an isosceles triangle. All right, so let's take a look at another one. So here we're also describing the cross section. This one, instead of getting a full plane and us having to find the outline of the cross section, we have to realize that what we have here is either a square or a rectangular pyramid. And then what we're looking at is the smaller figure with mostly dashed line sides is our cross section. So we're looking at this side, this side, this side, and this side being our cross section figure. Now, here's what we have to understand about the plane that is creating this four-sided figure. It comes through intersecting this side of the pyramid, say, and going out through the bottom of the pyramid. That is going to make the top and the bottom parallel to each other. And then because the sides of the pyramid are slanted in different directions, the two sides on the left and the right, or front and back here, depending on how you're looking at it, those would have to be non-parallel sides. So if we draw it more straight on, we'd be looking at it this way. So this is this side here, and this is the bottom here, and then it's connected like so. So you might recognize this particular figure and remember what it is called. When we have two sides parallel to each other with a four-sided figure, we call that a trapezoid. All right, moving on. So here's a practice problem for you to try. So pause the video, determine what you think the cross section is here. All right, let's take a look. So hopefully you came up with rectangle. Here's why it's a rectangle. So again, this gray rectangle here is the plane that's intersecting. We can see part of what I hope you recognize as a cylinder. So the plane intersects at the top of the cylinder, at the bottom of the cylinder, and then at the two sides, like so. Now remember, we're looking at this in perspective. So we're looking at this cross section at an angle, basically. So but we know that the top and the bottom of the cylinder would be parallel, and then the sides of a right cylinder would form right angles to one another, and that makes it a rectangle. Because if you were thinking parallelogram, then you need to realize that taking it out of the perspective that we're looking at it, we'd have right angles. All right, let's take a look at another one. Pause your video here and give this one a try. All right, let's take a look at this result. So your cross section, hopefully you came up with a circle. Again, it's in perspective, so it doesn't look perfectly round in the picture. But because of the perspective, when we take it out and let's say we turn the cylinder so that its circular base is toward us, this is what we would be looking at, which would be then a circle. Well as I can draw freehand anyways. All right, in the other part of this lesson, we're now going to be looking at solids of rotation. So this kind of takes what we were doing and goes the other direction with it. So in the problems we were just working on, we started with a three-dimensional figure and we looked at a slice of it, how a plane intersects that figure and what kind of shapes it might create. Here we're looking at taking a two-dimensional figure, a shape, basic shape here like a triangle, and we're going to rotate it about an axis. Or a line, basically. And that's referred to as solids of rotation. And this is another thing that we often have to do in calculus problems. So the line of rotation would be this line right here, which goes through one side of the triangle. Now, the idea is that every point that's on the part of the triangle that's on that line is going to stay right where it is. But every point that is not on that line that's part of the triangle is going to rotate in a circular motion around it. So we're going to take, say, this point here. It's really nice to do vertices, and it's going to rotate in a circle. And because I'm in perspective, it'll look more like an ellipse or an oval shape, but it's going to circularly rotate around. And it's like a reflection across that line. So it's going to reflect over here at some point when it reaches this side. And then it's going to continue its rotation going around the back to create a full circle and come back to its starting position. Let's take, say, this point here. So this point here will basically do the same thing. So it is going to start here and it's going to rotate in a circular motion around line L. So it's going to come around the front. Over here it would be a reflection of itself across that line, and then it's going to continue its rotation around the back to create a circle. Now the idea is every single point on this line here would do that same thing, and we would connect all of them over here on this side up to point A, and what we would have would be the shape of a cone. So that would be here. It says describe and sketch the figure that is generated by each rotation. So this right here, that's our sketch. And the description of it would be a cone. Let's take a look at another one. All right, so in this problem, we again have a vertical line of rotation, here line L. Our line of rotation does not have to be vertical, so you have to pay attention to where that line is in the diagram. All right, so like I said, every point that is on that line and part of the rectangle here would stay exactly where it is. But all of the points that are not on that line and part of the rectangle, they're all going to rotate around that line in a circular direction. So I like to start with corners or vertices first, and then I can do other things, other points too. So I'm going to start with point C here. So point C is going to rotate around the front. We'll get a reflection of it over here on the left side of line L, and then it's going to continue rotating around the back to create a circle. Point D, similarly, it's going to rotate around the front, create a reflection of itself, and then continue around the back to finish the circle. If I could take another point, say in the middle of my line here, I could rotate it so it rotates around the front, creates a reflection, rotates around the back to finish the circle. So you'll notice we do that with all of the points on line CD, that they would all connect over here. And so hopefully what you recognize here is that it creates a cylinder. So again, this is our sketch, and our description of it is cylinder, like so. All right, let's see what's next. So here we have a practice problem. So why don't you pause your video here and give this one a try. Notice that your line of rotation is horizontal, and so make sure that you are rotating your points in the direction that it goes around that line. All right, let's take a look at it and see how you did. So hopefully you came up with a sphere. This one can be a little tricky, like I said, so I'm going to take a moment to do it. So here is my line of rotation. It's a horizontal line this time. And so all of the points that are not on that line are going to rotate around that line. So let's take, for example, this point here. So it's going to rotate around, let's do the one at the top. So it's going to rotate around the front, create a reflection of itself down here below line L, and then it's going to continue coming back to its position to create a full circle. Same thing for other points. So this point would rotate around the front, create a reflection of itself, rotate around the back. This point comes around the front, creates a reflection, rotates all the way to the back to finish the circle. So if we connect all of these reflected points, it creates a sphere. So where this, if you recall from our volume unit, this would be right here a great circle. So that's a great circle there, but the sphere here may be a little better, easier to see in the diagram that's there. But this would be our sketch, and this would be our description. All right, so to close up this part of the lesson, I have here a problem where it's about rotation again, but this time we're taking this trapezoid and we're rotating it around line L, which is a vertical line of rotation. And it shows us here that this is actually what's created. So that's the shape that's created, or solid that's created. So my question to you is, how would you describe that? Take a moment, pause the video. All right, let's take a look. So how would we describe this? Because it's not by itself. So what we call this, if you recall, is a composite figure. So it is a three-dimensional figure or solid that is composed of more than one type of solid. So one way that we could describe it would be to say that it is two cones with a cylinder between them, or in between. All right, so that finishes up this part of the lesson. The second part will talk about nets, which is a useful tool when finding surface area of solids, which is what we're going to be talking about for the rest of the unit afterwards. All right, have a great day.